Hello everyone. This is Numeri Zaber. Today I gonna walk through my research project about AI power resume screening. Let me show the screen very well. Yeah, the AI power resume screening. This is my research project. This project was conducted as a part of my course for research and research in literature and technique at Texas A&M University and Commerce under the supervision of my professor, Dr. Su. So there are two parts of this presentation. The first one is the PowerPoint presentation. The second part is the demo. In the demo part, I will jump on my code and show you a very quick demo. Let's go through the introduction part first. The first session is introduction. The increasing adaptation of artificial intelligence, AI, and machine learning in recruiting has significantly transformed how organizations identify and evaluate the candidates. With the growing volume of application, manual resume screening process are inefficient, error-prone, and easily influenced by hidden bias. AI-powered resume screening offer a more efficient and equitable alternative by automating candidate evaluating through the intelligence system. The AI in recruitment and industry trend. AI hiring solutions have progressed from a basic keyword-based filters to advanced semantic model like BART and SBERT, which are capable of capturing deep conceptual meaning in resumes and job description. These advancement have significantly improved match accuracy and reduced the reliance on subjective human judgment during the hiring process. However, they have also introduced the critical concern related to fairness, algorithm bias, transparency, accountability that must be addressed through the responsible AI practices. Real world example of AI in recruitment. Several organizations have successfully integrated AI into their hiring pipeline. LinkedIn uses AI driven job recommendation and profile scoring algorithm to match the candidate to relate to relevant roles. IBM Watson recruitment employs cognitive computing to assess the application job fit based on historical success pattern. HireVue conduct AI-based video interviews that analyze the facial expressions and video voice to predict a candidate performance, while Paramedics applies the new neuroscience-based game to evaluate soft skills and cognitive attributes. These tools have reduced hiring time by up to 50% and improved the job fit accuracy by 40%. The challenges in AI-based hiring. Despite its promises, AI in recruitment faces key challenges. Biases in AI models, often inherited from historically biased trained data, can result in unfair hiring decision, as demonstrated by Amazon's discontinue AI a recruitment tool that penalize the female applicant. Furthermore, many systems operates as black box models, limiting the transparency behind the automation decision and decreasing recruitment trust. Explainable AI, XAI frameworks like SHAP and Lime have emerged to address this concern by increasing interpretability. The challenges in AI-based hiring. Additionally, excuse me. Additionally, ensuring the secure handling of candidate data is critical. Privacy preserving technique and emerging technologies like blockchain are being explored to enhance transparency and trust in AI-driven hiring system to remain effective in fast evolving job market. AI model must also be regularly updated to reflect new roles, skill set, and hiring patterns. Proposed work and unique contribution of this research. This research presents a AI-powered open source resume screening system that integrates the semantic understanding, model explainability, and user accessibility. It uses Sentence-BERT, that's called SBERT, embedding and cosine similarity for matching the resumes with job description, while an XGBoost classifier predict the job category with high accuracy, and SHAP is employed to interpret the model prediction, providing a recruiter with clear insights via a real-time streamlined web interface. Unlike a prior approach, such as enhanced resume screening for smart hiring uses Sentence-BERT, this system my research project is uniquely combined the SBERT, XGBoost, and SHAP into a transparent, scalable alternative to traditional black box hiring tool. The second session of this presentation research is literature review. The demand for efficient and unbiased recruitment process has driven advancement in AI-powered resume screening system. This section reviews the evolution of AI in recruitment, highlighting development in ML, and ethical considerations, real-world application, and comparative analysis. The evolution of AI in recruitment. Early AI hiring system relies on simple keyword-based ATS tools that lacked contents and rank candidate properly. As AI advanced, the models like IBM Watson Recruit introduced deep learning and predictive analysis to improve the screening. Recent development integrate the big data, IoT, and the social Internet of Things to enable the large-scale automated job matching. Transform-based model and neural networks allows for more accurate talent profiling while reducing bias in early hiring decision. NLP and resume parsing. The modern NLP has resume screening by transform unstructured data into a structure inside, while early system relied on TF-IDF keyword matching. Today's approach uses transform-based model like BART and GPT for deeper semantic understanding and NER to extract key details such as names, skills, and experience. This advancement outperform the traditional method by capturing context rather than just keywords. Additionally, multilingual NLP enables global hiring by processing resume across the different languages, crucial for remote and cross-border recruitment. Next is machine learning model for resume screening. Machine learning model has significantly enhanced the AI-driven hiring by improving candidate job matching accuracy. Some of the most widely used models, such as Random Forest and XGBoost, are used for ranking candidate based on historical hiring data. Support vector SVM are applied in classification tasks such as screening high potential candidates from large applicant tools. Deep learning model are neural network analyze pattern in hiring success to predict long-term employee performance. Machine in earlier academic approach, Bayesian network were explored for probabilistic models of candidate feature and job suitability scores, but they were limited by scalability and feature engineering complexity. AI-powered recommendation systems have also emerged, particularly in platforms like LinkedIn, Google AI Hiring, where ML-based scoring model assign match percentage between job seeker and opening. Ethical consideration in AI hiring. AI hiring system can reinforce biases when trained on biased dataset, as seen in Amazon discontinued tool that favor male candidate. To address this, debiasing technique and bias aware model are being explored. Another major concern is the lack of transparency in black box model, promoting the integration of explainable AI tools like SHAP and Lime to clarify the decision. Additionally, privacy and compliance issues have led to the adoption of blockchain for secure, verifiable resume data. Real world application and impact. Companies integrating AI into hiring have reported major efficiency gain, such as LinkedIn using AI-based job recommendation and profile ranking for recruiter. IBM Watson recruitment employs cognitive computing for candidate assessment. HireVue has implemented AI-driven video interviews analyze facial expression, tone, and verbal clue. Paramedics use neuroscience-based hiring assessment and evaluate the soft skill and cognitive abilities. Studies shows AI hiring tools have reduced hiring time by 50% and improved job fit accuracy by 40%. The comparative analysis, okay, this table one will show the comparative analysis between the related work that I already picked, the enhanced resume screening for smart hiring using the Sentence-BERT and my proposed system AI power resume screening. So if we go by step, like through the feature, like semantic embedding, the related work they use the SBERT. I also use the SBERT. For similarity matrix, they use related work. They use the cosine similarity, but in my system, I also use the cosine similarity. Classification algorithm, that one is not included in the related work, but I have included the XGBoost classifier. The explainability method, they are not included. I uses the SHAP. Then the education and experience extraction not specified. They did not specify anything over there, but I specify directly like species, NAR and regex. Deployment platform, they did not specify anything over there, but I mention it. I use the Streamlit web interface. Transparency, they are not open source. My proposed project is fully open source. User interaction not mentioned. Real-time resume upload and match score. Customizability limited and non discussed. Fully customizable, research and practicable. Use case, they basically use the SBERT for resume ranking based on SBERT and cosine similarity. Resumes, my proposed work is resume screening, classification, and SHAP based explainability. Uh, if we go to the efficiency, like we can see, they are saying the speed and efficiency, they are saying like 0.233 screen per resume, 90% accuracy, real-time scoring it gonna provide my proposed system and category prediction with a sharp insight. Bias mitigation discussion mentioned in the future work. In my proposed work, I integrated through the sharp exploration, fair insight, and decision making that we're gonna see in the next part. The next session of my presentation is a methodology. Let me- Okay, so how can I reshape it? Okay, um, okay. The next portion of this session is the methodology, and this is the methodology diagram that basically showing us the how the method gonna work. Technically, there are 6 key phrases. The first one is resume processing, feature extraction, ML model training, resume job matching, explainability, and AI power decision UI. The AI-powered decision UI, the first will be the screen. This and the second phase is the resume screening layer. Over there, the text extraction gonna be happen through the PDF Plumber and Python docx. Then the clear text NLTK and name entity recognition. We're gonna use the spaces for that. The feature extraction layer, we are using the SBERT embedding. Then the next layer is ML model training, split and split the dataset into 80/20 XGBoost classifier. The resume job matching, it will use the SBERT and Cosine and resume ranking algorithm. The next layer is explainability layer, the SHAP and influential word. Finally, the recruiter is able to see the match score, the category, and the influential word. Okay, the first layer it's gonna be the resume processing layer. In this layer, it handles the text, extract the text from the PDF or docx file by using the PDF Plumber or the Python docx libraries, respectively, and it also uses NER applies for the spaces to extract the structure information from years of experience. And I also use my own logic using by the regex for the education on all those information extracting. Additionally, it uses the NLTK for reduce all the irrelevant token and stop words. The first part is showing how the text extraction gonna be happen from the PDF and docx. Like we are seeing uh, this is a sample text in this table showing first is name, then the email, experience, education, all are structured data. When it gonna extract all the text, it extract as a string. Basically, it uses this library, the Python docx, and there is a PDF, then it gonna use the PDF library PDF Plumber library. The second part of the resume process layer is NER. So NER, we uses the spaces for extract the experience. This is the piece of code in the table you are showing. The first piece of code is extracting the date and quantity from the resume, say, and it gonna label it. So how it gonna do, like 10 years, if the resume has the 10 years experience, it gonna label as the quantity 10 years, and the experience gonna say like 2018 to 2020. That guy gonna work in this company, like it gonna label it as date. So in these two field, this two extraction gonna happen and gonna store for the experience purpose. And for the education purpose, I use the regular expression for that. This is the regular expression, like bachelor, master's, MBA, PhD, and whatever education does the candidate has. Based on that, it will fetch a JSON format, just like that. Education is a bachelor or master's or something like that. The second part of the resume processing layer is NLTK. NLTK, basically, I use it over here to clean the text, whatever we are extracting from the resume. The first thing is for the name. This is for NLT corpus name. It also it is extracting all the name from the resume, so the text gonna be clean. And the second thing is also extracting the stop words. Stop words in the sense, like if the string has a, the, is, all these words, it gonna clean it up, pick up all this thing and clean it up. Okay, so the next layer is in the methodology is a feature extraction layer. So we are seeing there is a data set call. In this layer, basically, as BERT converted the now we are part in this section of this methodology. We gonna work with the unstructured data. So unstructured data in the resume text. Basically, SBERT convert all the unstructured resume text into semantic embedding vector that capture the contextual meaning for a machine learning task. These embedding are paired with label job categories for training and classification model. This dataset is basically a CSV file. We need to upload it. We need to from this dataset. Basically, no need to upload. Basically, from this data set, the SBERT gonna read how many job categories are presently there and what will be the resume. There are two columns basically in this data set. One is category and another one is resume. The category column contain all the what kind of job category does it has, and resume is basically contain the text for that we can decide this category belongs to the candidate or not. This is the data set from where the we train the XGBoost classifier basically. So this is the table 6 is the SBERT embedding, how the SBERT embedding work, and the table 6 is showing. So first of all, it's the first step. It's gonna be the resume text. Say a resume contains such a text like experienced DevOps engineers with 5 years in AWS, Docker, Jenkins, or CI/CD automation experience. Then it gonna first step resume text. It gonna take the test and it gonna give the output like raw resume sentence. Second step, it gonna be SBERT model. Use this SBERT model by the let me mention one thing like for the SBERT there are varieties of model. So in this project I have used the all mini LM L6 V2 model and the SBERT. So when it extract the text, it use for pre-train the SBERT model process for the sentences. The tokenization, the next layer is it will break down the sentence into token, just like this way the experienced DevOps engineer, and the token process output gonna be token process with position and contextual in engineering. Embedding generation SBERT encodes the entire sentence, capturing meaning and context. A dense vector like 384 dimension. It will create a dense vector of 384 dimension. The example vector output 0. This is the exam vector output 384 dimension, and it gonna semantic embedding represent the whole present sentence. The sixth step is use into the ML. So whatever 384 vector dimension we are getting, so in the next layer we gonna feed it in the XGBoost classifier with the level, whatever level we do have, like a DevOps and all those things. So next layer is the machine learning model training layer. In this layer, basically, we in the system we use the XGBoost classifier for multi-class classification of resume into predicted job categories. The training dataset is 80 by 20 split, contain level resume across the diverse tech role. XGBoost is chosen for its robustness with high dimension and imbalanced data. The classifier is evaluated using precision recall, F1 score, and accuracy metrics to ensure reliable performance. Okay. Over here, the machine learning model layer, training layer, is this table is basically table 7 is showing the XGBoost classifier, how it's working step by step. The first step is gonna be input embedding from the SBERT. Whatever the embedding we getting, like a 387 dimension, it will take it input and numeric feature like a vector. The purpose of this method is resume text transform to numerical form. The second step is assign numeric job categories to level encoder. So say like it get DevOps level, it will assign it the 0, and data science it will assign it to 1. The third step is a train test step 80 by 20. I'm gonna explain everything in the code level. That will be more easier. The fourth step is a train XGBoost classifier. XGBoost classifier learn how to classify the based on the embedding level. The fifth step is boosting build tree sequentially, graduating boosting. Sixth one is test the model on unseen data. Model prediction XGBoost test. Evaluation model performance. The third layer of the methodology section is a resume job matching layer. In this layer, the system employs SBERT to compute meaningful sentence level embedding for resumes and job description. Unlike traditional BERT, SBERT uses this CMC network architecture to generate fixed size vector represent of entire sentence of document, making it highly suitable for semantic similarity task. Cosine similarity is applied to calculate the closeness between a resume and a job description. Suppose a resume is giving classified as highly relevant when the percentage will more than 75%. Moderate match it gonna be like 50 to 74%, and not a good match that means it gonna be less than 50%. Based on this score, it's basically calculating the cosine similarity and SBART symmetric calculation. So how the SBERT and cosine similarity does it work in a single short description? I can say like SBERT basically convert the entire sentence or a paragraph into a dense numerical vector that captures the semantic meaning, not just the keyword presence. Like there is an example from the resume. We fetch a string or a text, something like calling a experienced Python backend developer. So what does is but do? It's basically convert the entire this string to 768 dimensional vector, just like this way: 013, 014, 0158, blah blah blah, then 01. So once it get the two vectors, so one vector is from coming from the resume embedding, resume string, and another vector is coming from the job embedding. That means the job description that is provided by the recruiter. So whenever the this two vector is collected, what does the cosine similarity do? It checks how close they are in the two vector are in direction, not magnitude, and gives them a score based on 0 and 1, where 1 is perfect symmetric match and 0 is unrelated. This is the main, if I go through a short description, how the SBART and cosine similarity work, this is the main description of it. The second part, this figure 2, this is basically showing how the code has written in my project. The match resume with job, match the resume with the job description. The first of all, in this function, we are saying we are taking to a string the resume text and job description. This resume text is extracted from the resume, and job description, that one is provided by the recruiter. And it's firstly is checking whether the job description is null or not. If it's null, then it's a return a zero value, and asking to the recruiter, hey, job description is null, you need to provide something. If it's not null, then what it's doing, it's directly calling the cache embedding, the SBERT embedding, which I keep it in the cache for boost the performance, because it's taking too long time to learn it. So first of all, it send the resume to the cache embedding, and the secondly, the job description, it also send it to the again the cache embedding, and get the job embedding. When it receive the resume embedding and job embedding, the cosine similarity, what does it do? It basically matches the both dimensional vector, and return a value like 0 and 1, whether it's relevant or irrelevant, as I mentioned before. Basically, this piece of code is working like that. The next layer is explainability layer. In this layer, we see we have used the SHAP. Okay, SHAP is used to enhance the transparency and resume screening by identifying which resume words most influence the model's job category prediction. Although the model uses non-human readable embedding, SHAP track back the contribution of individual token and highlights the most influential word, making AI decision fairer and more explainable. Say like I have suppose the resume contain the following sentence like experienced DevOps engineer skill in AWS CI/CD Docker. What does SHAP do? It might basically pick all the relevant word. Like if I go to the DevOps, it will give a score like 0.25, AWS 0.20, Docker 0.18, engineer 0.10, scales 0.07, but on the other hand int is showing like irrelevant because in is not a part of influential word. The last part of the methodology is web-based deployment. In this layer, basically, I use the Streamlit-based web interface, which enables the recruiter to upload a resume, input job description, and receive the classification results along with the match score, explainable keyword. We also display the education and experience detail extracted using NER. This real-time user-friendly interface ensure a seamless recruiter experience. The application process uploaded resume in real time, display the match score and extracting skill, education and experience. This methodology ensure an efficient and unbiased research screening process, leveraging state-of-the-art NLP, ML techniques and explainable AI, XAI. For next session of this research is implementation and experience. Okay, so the AI-powered resume screening system is built based on the Python 3.1 version. It's integrating NLP, ML, SBERT, and XAI SHAP into a web-based application. I use the Visual Studio IDE Windows 11 with an Intel i7 processor and 16 GB RAM. Dependencies managed via PEEP manager and deployed using Streamlit for real-time recruiter interaction. Core components include resume parsing, feature extraction, SBERT embedding, XGBoost classifier, cosine similarity matching, and SHAP-based interpretability. The system uses CSV dataset of synthetically labeled resumes like software engineer, data science, cybersecurity analyst. Resume are transformed into 768 dimensional SBERT vector using the model all mini LM L6V2. This classified with the XGBoost max depth is 5 and estimator is 50 and tree method uses by HIST. The Streamlit UI displays match score, confidence level, extracted entities, and sharp explainable features, ensuring a model transparent and explainable AI system. So technically, this table 9 is showing what library I have used so far and what are the tools I have used. Like firstly, I gonna say like Pandan, NumPy. These all are most famous and commonly used libraries for data processing and matrix operation. The Visual Studio, that is the IDE. PDF Plumber and Python docx I uses for file parsing. For PDF Plumber, I uses for the PDF, and docx I uses Python docx I uses for a doc Word file. Streamlit is basically a web building and deploying interacting web dashboard, very lightweight. Spaces and NLTK. It's we use I use for tokenization, name entity recognition, and text cleaning. SBERT for generating contextual semantic embedding, all mini LM L6 V2 model. XGBoost classifier for multi-class classification of resumes into job categories. SHAP, I used SHAP for interpreting and visualizing features, importance behind the model prediction, scikit-learn for evaluation metrics and level encoding. The next part is the result. Technically, this is basically the research result. I have gone through few more resumes in my project, and I find out some of the result. This is the GUI part. Like you guys are seeing from the first is the title AI power resume screening. Enter the job description, what their recruiter can provide a job description, and upload a resume. Based on that, it gonna show the resume match score first of all, and underneath of it is gonna show how what kind of match it gonna be. In the screen we are seeing it's a modern match. Education experience, it's clearly mention everything. Later on it's mentioning the model trained successfully, predicted job category, and top influential word. Technically, firstly it's matching the contextual meaning, and giving us a score, match score. And secondly, the second part of the of this GUI, whatever is showing, is fetching from the resume. The education experience, predicted job category. Predicted job category is basically like what kind, based on the resume we have uploaded, and based on that it's saying what category this candidate will be suitable for. So right now, till now, this is the presentation. Let's second part of this presentation. Let's jump on the code, so I can show you a very quick demo about it. Okay, so yeah, this is the code. I have uploaded my code in the code base like GitHub, and I will provide all the URL to the description box. You guys can check later on. So let's very quick jump on the code, and I'm gonna show you very quick about my research and all those things. The first of all, these are the imported library. I have imported like Panda, NumPy, ARI. This is regular expression, docx, PDF plumber, spaces, NLTK, Streamlit, SHAP. And a sentence transformer for SBERT, the cosine similarity, train test split for the XGBoost classifier, level encoder for leveling, XGBoost classifier, name and stuff. This is coming from NLTK. The first piece of code, like load NLP resources. I loaded the NLP resource from the stop word, like and if or all those things. Then I'm loading the names, and secondly, it's also loading the spaces. This is the model. En core web SM means small. I'm loading the small model of the spaces. The second part of the my code is load a pre-trained SBERT model caches for performance. Okay. So over here, what I'm doing, I'm loading the SBERT model. This is the model name. As I mentioned in my presentation also, all mini ML L6V2. And this is the sentence transformer. I load it and keep it in the cache of the Streamlit for the better performance. Okay. The next one is the load SBERT. Load SBERT is basically is calling that function and assign this return function return value into this variable. The next one is it's basically fetching the name from the whatever name I have using, and I create a nameless variable, then a stop word variable, and I also create a array for irrelevant token, which is for name, address, street, city, state, road, main, all these things, whatever we've commonly find in the resume. The next portion is the load dataset with the class mapping. Okay, this piece of function is basically loading dataset. As I mentioned in my presentation also, the resume data, this is the name of the dataset, resume dataset CSV. Technically, I keep it in the same directory wherever I keep the project. Let me show you very quick where it's coming. Okay, technically, this is the data set basically. It's a CSV file. From this file, it's basically loading all those categories. Okay, so for all the categories along with the resume. If you see, there are varieties of categories like data science, HR, and all those. I mean, this is basically job category along with the resume. There are two columns, category and resume. And resume contain all the skill set, and category contain all the category does it has. Okay, now it's basically load the data set. First of all, if data set had no value must contain, it's giving me an error, like it should contain two column. Then it's fetching the two column value and store it and return it. The second phase is this function. In this function, like it's basically extract the text from the PDF docx. In this function, it's basically getting a file path, and first of all, it's checking the file extension, whether it's PDF or docx. If it's PDF, it jump on over here and extract all the text from the PDF value by use the PDF number. And if the extension is not PDF, then it will check whether it's a docx file, then it will extract all the text and return it. The next portion is the name entity recognition NER for experience and regex for education. This function is basically taking as an entire text we are fetching from the resume, pass the value over here, and when it's come, it collect the date and the quantity, as I mentioned in the presentation also. Like date means how long from where to where, like 2015 to 2020, this guy is working in this company, and how many years, like 10 or 20 years, fetching and extracting, and it also summarize over here. Summarize the job experience. How many years, like 20 and 5, like 25 years, it can extract and summarize everything. I will show it that portion also. So later on, like extracting the education, this is an array. I have declare it. How many education does it has? Like a bachelor, master's, MBA, all this thing, and create a set for that. And based on that, I use the regex. If it found the regular expression matching with this format, then it extract the education from there. How many years, and returning the value, experience, and education from this function. The next portion is cache SBERT embedding. Is it's basically cache all the data from the cache SBERT and return the value, receiving a text and cache all the data from the SBERT. The next function is XGBoost classifier model with the evaluation. Excuse me. This function is basically XGBoost classifier we have used. We load the data set, then calculate all the embedding and classifier, train the data set also into 80 by 20, and then later on it return the model along with the level and the extrain version also. The final portion is coming through the SHAP. SHAP is basically like for the transparency and the influence word we use over there. It received the model that it got from the XGBoost classifier and the resume text. It get the data. First of all, it get the data from the cache embedding. Then the model also SHAP explainer, then explainable embedding. Uh, After doing all this thing, technically, what does it do? It also do a regex, make it raw data and clean the word. Clean word means it also name list, irrelevant token, stop words is checking is the if the word is available on that list or not. Name list for names that I mentioned before, irrelevant token that I also mentioned, stop words, and also these are the regex. It's also checking the clean word is the part of first one is the uh, sorry, this one is the mail. The first one is the phone number. The third one is there any HTTP or www URL? And the fourth one is a LinkedIn or GitHub, any kind of URL. Not technically, we provide all those things in our resume. It clean up all those data from the clean word and return the influential word. Okay. Now, match resume job matching, like this is for SBERT and cosine similarity. He's sending the match score that first of all, it's checking whether the job description is null or not. If null, then it's return zero, asking for an entry something. Then the cache embedding and the cache through the resume text and job description. I mentioned this piece of code in my PowerPoint presentation, so I'm skipping this one right now. The Streamlit web dashboard. This is the basically main piece of code where the dashboard gonna play. This is the title, job description is asking for enter a job description, also asking for upload a resume so it can upload something. Then from the uploaded file, it's checking whether it's fetching all the data like extract text, file path, resume text, extract resume entities. Then later on, please enter a job description, calculate match description, job description to calculate the match score, match resume with job. This is calling that function. Later on, resume match score is showing the match score. If the match score is more than 75%, as I mentioned before, also it's gonna show the high match, the resume score aligned with the job description. If greater equal to 50 to 75, it's gonna show the moderate match, and less than 50, it's gonna show the low match. It also show the education and experience underneath of that is the all piece of code. And at last it gonna show the predicted job categories along with the confidence that candidate has. Okay. And underneath that it will show the top influential word in the resume. Is if there is no influential word, it gonna show that one, and if there is any influential word with prediction, it will show also this one. So this is the code of my project. So let's do a quick demo of my code. I have shown the code base. This is my code base. First of all, you guys need to create a fork of my project and clone it. After cloning it, you have to install all this thing. If I gonna try to install it right now, I'm gonna, because I already have installed it, it's gonna show me all are satisfied. Requirement already satisfied, all are showing something like that on my end because I have already installed this thing. All the libraries I have installed. Okay, now I'm good. Now the next portion is that to run this application, what I need to do this piece of command. Sorry, guys, it's taking little time. Okay, I need to run this Streamlit run, then project 6 VY. V6 PVY. This is the file name, projects underscore v6.py. I need to run this Streamlit run project v6.py. Let's hit the enter. Okay, now it's gonna open a browser in a new tab. It's showing like a, okay, it's showing the system is running. It's running and a little busy. It's gonna take a few time because it's loading the SBERT and train it and keep it in the cache of the Streamlit. By default Streamlit is running over here like in my computer 8501. It's running in the local host. Okay, now it's running the load the SBERT model. Okay, bingo. So this is the GUI for that, and it's also asking like enter a job description and upload a resume. So technically, I have some demo, a sample resume in my code base, and I also create some job description for that. So let me jump on the last one first. It's a okay, not this one, last one. Okay. Hmm. Let me go inside my. Okay, let's jump. This is the resume 12. I'm uploading this one. It's a PDF format. Okay, now it's showing because the resume match score is 17.11% match. Low match resume has limited align with the job description. Why? Because I have not provided anything. It's asking like enter a job description. If I delete it, and let's see what I'm gonna say. Okay, please enter a job description to calculate the match score. Now it's complaining like my job description is null. Okay, so the resume I have uploaded, that resume is basically one candidate which who is a CEO of a company. So I have created already prepare a sample for that, the job description. We are looking for an experienced CEO to lead the overall company's strategy growth operation. The ideal candidate must have proven skill, all this technology, blah blah blah. Okay, I have provided this job description. Let's jump on. The resume is already updated, uploaded in the portal. Now it's showing the 66.95% match. The modern match partially aligned with the job description. The education is fetching business administration 2002, my MBA 2005. The model trained successfully. The first um, category is predicted. Operation manager 51.12% confidence. Database 13.39. Data science 5.10 confidence. ELT developer 3.32 confidence. Network security engineer 2.68 confidence. Okay, let's jump on the top influential word. It's saying like a top influential words are predicted. Chief Executive Officer CEO summary. Okay. Now let's go to the resume. Resume 12. Let's see what does it say. So technically, this is the resume of an candidate who is the CEO of a company, and he has a very good experience, like over 20 plus years. But let me see. He has completed his schooling. Okay, BBA he has completed in 2005, and MBA 2000. Sorry, BBA 2002, MBA 2005. Those are correct. 2002, 2005. He's a good operation manager. There is no doubt about that because he is the CEO. He has been working. So based on this educational degree, we can say like he has 26 years job experience. It's mentioning over here because it's summarized entire job experience from 2002 until to now, till now, 2025. He also worked as a CEO of this one. Before that, Vice President of Strategy, Education, blah, blah, blah. Okay. So right now we can say this information we are getting is aligned with the contextual matching and all those things. The SHAP is also working smoothly along with the influential word. Now let's jump on another resume, which will give us another view of uh, let's go check the resume of resume 11. Okay, let's see what does it say. Cool. This candidate education is a BFA in graphics design, School of Virtual Arts, Network, New York, graduated May 2017. Okay. Predicted job category is showing 28.58% confident, data science 18.99, web designer 12.50 confidence, and influential word is showing graphics designer, New York professional. Okay, technically, I can say like job prediction is perfectly aligned with the influential word. It's fetching correctly, education also fetch correctly, but you see the match score is going down because I have not changed the job description. I have to change this one because this candidate does not has the job description I have provided before, that was is for the previous resume. So let me fetch a good job description for this candidate. Okay. We are looking to create a detail oriented graphics designer to join our team. The ideal candidate must have a BFA and equivalent degree, blah, blah, blah. Okay. It's loaded. Bingo. Now it's showing like 71.04% match, moderate match, because whatever information we have provided, it's matching with the job description. The semantic embedding and cosine similarity is working smoothly over here. That's why it's showing the job description and resume text is matching properly. And remaining information will keep same because unless we are not change the resume. Let's go inside the resume and we will see the what the resume is saying. Okay. This candidate is a graphics designer. Okay, yeah, technically 5+ years of experience, visual studying, banning, in New York, yeah, 2001 to 2026. He has education BF in graphics design, School of Virtual Art, NY. Okay, certification of Adobe Certified ACE, course handling. Okay, so we can say like this candidate is a good candidate for as a graphics designer. So that's why the match is showing 71.05, and the below underneath that it's the after the education is correct. Technically, he graduated in 2017. Yes, that's also correct. And it's an art student art exhibition. Okay, and the job prediction is also correct because he has the confidence on art, data science, web designing, databases, and influential word are graphics designer, New York professional, blah blah blah. Okay, that sounds good. Let's update the job description and let's see what it gonna say. The other hand, if I say like we are seeking a candidate for 10 years Java developer and 5 years DevOps engineer. Okay, let's see what does it say for the match score. Bingo, you see, it will go down, low match. The resume has limited alignment with the job description because this candidate does not have that much experience as a Java developer or neither a DevOps engineer. Technically, he's a graphics designer. If you go inside the resume, you see he has all the graphics designing experience and all those stuffs working experience. Okay, now let's jump on another resume. Resume 10. Okay, I'm not changing anything over here. Keep the job description same. Okay, now it's showing like low match. Resume has limited align with the job description. Why? This is a doc file I have uploaded. This is a docx file. Previous two resumes was a PDF file. This is a docx file. Let me see what does it say. Okay, so this candidate is a very he has a bachelor degree in computer science from some university, experience 11 years experience, good experience, but he is a DevOps engineer. Okay, 24.75% confidence, Python developer, okay, data science advocate and automation testing. Influential words are cloud solution architect experience. Okay, so why not I just resume delete it and I say we are looking for a candidate for 5 years DevOps engineer. Let's see what does it say. It goes down. Okay, so technically what we need to do, this candidate is a cloud solution architect. Let me put this one. We are looking for a cloud solution architect and hands-on experience like AWS, Azure, and GP, transferring cloud native architecture and responsible including design, implementation, scalable multi-cloud infrastructure. Now let's see what does it say. Bingo, you see that the resume now it's the match score is showing 74.53%. It's a modern match. Why? Because this candidate has a influential word is cloud solution architect experience. You see that? Though it's, the category is providing DevOps, but technically he has a very good AWS architect. Let's go inside the resume, then we can strongly say that the it's yeah cloud solution architect experienced cloud solution architect with 11 years experience in building managing and optimizing system and tools skills in modern technologies and collaborative development. His skill set is belongs to AWS, Azure, GCP, Transform, microservice, and load balancing. Okay, he does not exactly we can say like he's a cloud guy, cloud solution architect, not a DevOps engineer. That's why the category was going down. Yeah, I mean the percentage was going down. Okay, so let's jump on another resume, the last one. I'm not gonna change the description. Okay, this is a resume for a DevOps engineer. Let's see what does it say. Okay, bingo. It also showing the modern match because he has a DevOps engineer. So that's why he's saying like it's 55.25 modern match. This guy is partially aligned with the job description. He's a very good candidate for the DevOps engineer because he has the experience in software developer, result driven years of experience. Let's go inside the resume. Okay. So he's basically a software guy, 10 years experience. He work in varieties of language like Java, Python, JavaScript, C++. He has 10 years of experience. Yeah, that's true. He has completed his schooling, Bachelor of Science in Software Engineering and Computer Science, 2012 and 2014. Let's see. Yeah, Bachelor of Science in Software Engineering 12 and Computer Science in 2014. Both are correct. Influential word is software developer, result driven, years of experience. The category, the first one is DevOps, the second one is Java developer, third one is Python developer, blockchain, automation testing. Okay, now if I remove this job description because this job description belongs to the previous resume, and if I say simply, we are looking for a Java developer, sorry, Java and DevOps engineer. Let's see how it does behave. Yeah, bingo. It goes little up. You see that? So we are looking for 10 years experience, Java developer and DevOps engineer. Bingo, it's going up. You see that 52 to 54. The parts, the semantic embedding, its a percentage is contextual meaning percentage is going up. Match score is going up. Bingo, it's going down. Only Java we are looking for. But if I say more DevOps, it going up, lower up. Okay. So now the thing is that like if we are looking for a Scrum Master in this resume, what it gonna say? Bingo, it will go down to 30%, 30.75% match, low match. Resume is limited aligned with the job description. Technically, he is not a Scrum Master. He is a good developer. This resume belongs to a good developer with the DevOps engineer. Remaining part will keep same. The education experience all will same. If we job category and influential word, this portion is coming from the resume, whatever the resume we are uploading. But this match score is basically coming with the job description and the resume text. Okay, these are the four resumes that I have shown you in my presentation. I believe you guys like my presentation very well. And I also have updated all my code in the code base GitHub. You guys can download and play with it. So thank you, all of you, to see my presentation and see you in the next video. Thank you, all of you. Bye.